Good morning, everyone. Am I audible?
Yes, sir.
Am I audible?
Yes, sir.
Okay. So what we have discussed in the last class? Did I give you any assignments? Actually, I forgot. Someone please remind me whether I have given any assignments to all of you. Okay. But that means till now we have discussed what is finite automata, what is language, okay, what is transition diagram, what is transition table, and what is DFA and how we can define a DFA from a language by using some input symbols. Do you have any confusion in DFA? Anyone have having any issue in DFA? Is it clear now, David? Is my voice is clear now? Okay. So till now we have discussed deterministic finite automata. That means by using some predefined steps, we are going to study about the machine which we use on daily basis. Because automata means study of machine. Finite means some specific or definite or defined, and deterministic means fixed. Okay. By using some predefined steps, we are going to study about the machine, that is called DFA. Now, sometimes what happen, we cannot depend on DFA only. That is, every time, in simple term, in every time it is not possible to study about the machine by using some predefined symbol or predefined steps. Or sometimes, in some cases, it is not enough. In some cases, we cannot define some specific steps. There are so many circumstances. Okay. Or sometimes we cannot find out what will be the exact steps to perform the following operations. So in that case, or in such cases, we have another type of approaches using which we can do our study, is called non-deterministic finite automata. Non-deterministic finite automata. Okay. What does it mean? Anyone can tell me what does non-deterministic mean? क्या हो सकता है नॉन डिटर्मिनिस्टिक का मीनिंग क्या हो सकता है? एनीवन? So we have studied about the deterministic one. Now we have another type of approach to study the same machine or similar kind of machine. It's called non-deterministic finite automata. In short, it is called NFA. That means we have two type of approach. One is called DFA, one is called NFA. So what is DFA and how it works, we have already discussed, and I hope you got some idea about DFA. Now we have to discuss about NFA, non-deterministic one. Anyone have any idea? Not bad. Jitul, yes. Actually, whatever you have said, the actual meaning is same, but the way you are expressing your point of view, it's not exactly correct. That means in some other way we have to express it to which meaning is almost same with you. Anyone else? और कोई जिसको जिसको थोड़ा बहुत आइडिया है, मतलब कि ऐसा हो सकता है? नॉन डिटर्मिनिस्टिक मीन्स और एनडीएफए और एनएफए मीन्स दिस वन मे बी और मे नॉट. लुकनो, गुड. गूगल पे सर्च करके मत यहाँ पे पेस्ट कर देना, ठीक है? यू हैव, आई वांट योर idea only. It may be correct or it may not be. I'm not going to judge you, okay? So it's simply whatever you have understood, simply express your ideas here. But whatever you have said, look, it is almost correct. David, the machine can move to any combination of states in the machine. It's correct, but not appropriate. Yes, move any combination, but it should be better. Anyone? Anyone else? Okay. Now we are discussing non-deterministic finite automata. Deterministic means fixed. That means if we are in state Q naught, we have input symbol 0, then we will reach Q1. It is fixed. If we are state in Q naught, we have an input symbol 1, we will reach Q2. It is fixed. Matlab means if we are using 0 at Q naught state, okay, it is fixed that either I will get Q1 or either I will get Q2 or either I will get Q naught itself. It is fixed. Okay, that means the basic criteria of DFA is that using one input symbol, there may be multiple input symbol in a single state, but for each and every state, okay, for one input symbol there is one output state. That means we cannot go from Q naught to Q1 by using 1 as well as Q naught to Q2 again by using 1, either Q1 or Q2. But in DFA, as its name explain, non-deterministic one, that is, it is not fixed. That means we can go to Q1 by using 1 as well as Q2 as well as Q3. That means multiple, using one input symbol, I can go to multiple states. It is not fixed. That's why it is called non-deterministic finite automata. That means the steps are not fixed. You may, as suppose who told that, as look no, mentioned a system in which the output cannot be predicted because there are multiple possible outcomes. That means for in DFA, if we are using 0, that either I will get Q1, either I will get Q2, either I will get Q3 dot dot Qn, any one of these series. But that means in that case we can predict that if we go through the diagram, transition diagram, you will find that from Q0 to Q1, if we are using 1, then from Q0 we get Q1. But in NFA, we cannot predict it completely. We can say that we may go to Q1, we may go to Q2, we may go to Q3, but it is not fixed that we simply go to Q1 only. That means there are multiple outputs. That means the basic difference between NFA and DFA is in DFA using one input symbol, there is one output state. But in NFA using one input symbol, there are maybe multiple output state. Okay, is it clear? Is it clear? Okay, next go back to DFA. In DFA, what we have to do? Suppose we have two input symbol, we have to apply each and every input symbol. We have to apply all the input symbol to each and every states. That's why we have a concept called dead state. I think all of you have remembered, because whenever we have go through the uh, designing portion, you have to add plus. You have to use a dead state to complete the diagram. Okay, I think all of you have remembered, and you have already implemented the concept called dead state. But in DFA, it is not mandatory that all input symbols should be applied in each and every state. For example, suppose when you are at home, some things are mandatory, that in morning or evening you have to go to your table, study table. तुमको पढ़ना ही पढ़ना है. अगर नहीं भी पढ़े, you have to sit in your table for a specific period of time. तुमको सुबह इतने बजे उठना ही है. It is fixed. शाम को तुमको टेबल पढ़ना ही है, सुबह को तुमको पढ़ना है, सुबह इतनी बजे उठना है. It is fixed. It is mandatory, suppose. But when you are at a hostel, do you follow the same routine? कल तुम लोग का एग्जाम है, तुम दिन भर पढ़ोगे. एग्जाम नहीं है, ना सुबह उठोगे, ना पढ़ोगे, ना इवनिंग को पढ़ोगे. So in DFA, it is mandatory to apply all the input symbols to each and every state. That's why we have to use the concept called dead state. Because without applying all the input symbol to each and every step, your DFA is incomplete. But in NFA, it is not mandatory. From Q1, suppose we have an input symbol 0 and 1. I think whenever I am discussing this point, I think you are able to visualize the transition diagram. Suppose we have a state called Q1. From Q1, I am using 0 to reach Q2. And I am not interested to use one input symbol on Q1 state, so simply leave it. Okay, that means another difference of DFA and NFA is it is not mandatory to apply all the input symbols in each and every state. जिस स्टेट में तुमको जो इनपुट सिंबल चाहिए उसको यूज करो, रेस्ट इज इग्नोर. यू कैन ऑल्सो अप्लाई, बट इट इज नॉट मैंडेटरी. जब मैंडेटरी नहीं है, यू कैन स्किप. Do you get my point? Basically, DFA and NFA is almost same. Not exactly same. Their motive is same, but their way of doing their study is something different. In one, everything is fixed, everything is predefined. In one, it shows the possibilities. There is no fixed term. It shows the possibilities. From Q1, you can go to this line using this input symbol. Out of this, you have to select which is your appropriate one. In DFA, you have to use all the input symbol. तुमको हर input symbol में तुमको transition करना ही है. अगर नहीं करोगे योर DFA इज इनकम्प्लीट. बट इन NFA ये तुमको नहीं चाहिए मत, इग्नोर इट, लीव इट. These two basically, these two are the basic difference between NFA and DFA, but both are uses in the same course called study of the machine. Okay, is it clear? Is it clear to everyone? Okay, good. But I think there are 12 participants. Someone leave and did not join. मैसेज करो किसने कौन कौन किसने लीव किया है, उसको ज्वाइन करने के लिए बोलो, क्योंकि रिसेंटली देयर आर 12 पार्टिसिपेंट. किसी एक ने, डेविड, सर डेविड ने, और डेविड तो है, जिसने भी लीव किया उसको फिर से बोलो ज्वाइन करने के लिए. मीटिंग अनलॉक ही है, ठीक है. नाउ कैन एनीवन टेल मी one similarities between DFA and NFA apart from the point called it will uses to study about the machine. Except this point, can anyone tell me any similarities between NFA and DFA from whatever you have understood? Can you find out any similarities? Any one or two? Any one or two? Yes, good, Jitul. So that means, in simple term, you can say that in NFA we are using the same 5 tuples which was used in DFA also. जो हमने DFA में यूज किया था, कैपिटल Q, लिस्ट ऑफ स्टेट्स, then summation, suppose input symbol, delta, sigma, okay? Then Q naught, input, start state, and F, state of final states. That means in NFA also we are using the same 5 tuples. Anyone else? Anyone else? So you write the definition. A non-deterministic finite automata. So before going to give the definition, I want to show how much you have understood and write one. uh, okay, write one example. Let's see how much you have understood. Design a NFA for the language L. Design a NFA for the language L. L. All strings over. That means the input symbol 0 and 1 that have that have at least two consecutive zeros and ones. That have two consecutive zeros and ones. You try. Means the idea is same. How you normally uh, design the DFA, the same way you have to design the NFA. But the difference is that in DFA you cannot use the same symbol to reach multiple states after language. Define a NFA for language L equal to all strings over 0 and 1. All strings over 0 and 1 that have at least two consecutive zeros or ones. That have at least two consecutive zeros or ones. Okay. In NFA also there must be one start symbol and there must be at least one final state. Oh sorry, initial state, maximum one initial state and minimum one final state. That means more than one final state can be available in NFA also. Same arrow, same circle, same double circle, same you can use self loop. In NFA, no need to use the concept of deadlock because you can ignore input symbol if it is not going to utilize or it will not going to help you to create the string. That means the whole thing is same, but you have to find out the difference, sir, or to at least two consecutive zeros or ones. Two consecutive zeros or ones. That means at the end of the string, either two zeros or two ones, not maybe the end, in between also. You try. Only Saidur have submit. Saidur, can you draw it little more accurately? Because it's not like that you simply avoid one input symbol in throughout that diagram, transition diagram. You have used only zero in two states. It's not like that. Either, although it is not mandatory, but it's not like that you simply avoid one symbol in the entire diagram, because it is clearly mentioned that either two consecutive zeros or two consecutive ones. Okay, since one symbol is present, you have to utilize. But in some cases, suppose like suppose in previous one, in some cases in DFA we have to deadlock to complete. So in such situation, in DFA you can ignore the input symbol, but it is not like that you can ignore one input symbol you are throughout the diagram. It's not like that. Okay, in DFA some situations arise where you have to use deadlock, sorry, dead state. But in NFA, if such kind of situation arise, you can simply avoid this input symbol. But it does not mean that you can avoid the input symbol throughout the diagram. I think it is clear to you. To from Q1 to Q2, in which direction you have apply? You are almost correct, but slight mistake. Minor mistake is there. Uh, Class. This meeting will end in I think 1 or 2 minutes. So everyone try to complete this. Okay, you can share me in the WhatsApp. Okay, I have to leave now. I have some work regarding the convocation. All of you take your time, go through it. Okay, we'll discuss tomorrow again. But you take your time and try to complete. Remember the points whatever we have discussed and try to apply it